What do you think? Yes. Thank you. Now we're cooking. As I say, my name's Matt Welcome. I wrote this this book a while back called A Brief History of Timelessness, and they asked me to come and talk about at this wonderful ball. My book will explain to you why it's always now everywhere, live here at the Royal Greenwich Observatory. The Royal Observatory is famously linked with sailing and time. King Charles II found it in 1675 to solve the problem of finding longitude at sea. Does anyone here already know that? Excellent, of course, a lot of people should know that. And this is the Greenwich time ball, which drops, they raise it at a certain time and drop it at a certain. Does anyone know what time they drop that ball? 1 o'clock, midnight. You wouldn't be able to see it at midnight, would you? Midnight. Did anyone see the ball drop? No. I know mine did at midnight, but that's a different story. And to solve the problem of longitude, they had to invent very accurate clocks. This guy here is called John Harrison. He invented some of the world's first most accurate clocks. This is one of his most accurate clocks. The Royal Observatory of Greenwich, if not the birthplace of time, is at least the home of the planetarium, the Royal Observatory, the Meridian Line, and Greenwich Mean Time. This area where you are now is very famous because it's one of the few parts in the world where you can stand literally with one foot in the Western Hemisphere and the other foot in a pile of dog poo. So it's a very unique part of the world. So what is this presentation about? And what is a brief history of timelessness? This presentation is about time, or rather timelessness, and this is the book that I wrote. It's 500 pages thick, it's 250,000 words. It's all about the fact that there is no such thing as time. I can explain that to you. How did it all start? It started one day as I was having a very relaxing bath, waiting for a sunset, when it suddenly occurred to me that everything that is happening anywhere and everywhere in the world must be happening now, and in the entire universe. If you think about it, it's obvious. Every blade of grass and every field is moving slightly now. Every bird, whether they're flying or sitting on the ground, is moving slightly now. All the ships in the sea are moving. The earth is constantly spinning. The sunset is not a time, but it's a place. It's that gap there where it goes from light to dark. There's always a sunset. We could fly over there and have a look at it if you want, and then fly back if you had the right kind of airplane. The sea is always moving, the planet's moving, the stars are forming and dying, and we're thinking, and trains occasionally run on time. Then it occurred to me that we seem to just assume that it's obvious that time exists and that things happen over time, whatever that's meant to mean. People say things happen in time, with time, through time, over time. As Sherlock Holmes said, it's often a mistake to accept something as true merely because it's obvious, but we seem to obviously think that time exists. Einstein once said, and this was in a letter to the widow of his best friend, Martin Beeso, "For we convinced physicists the distinction between the past, the present and the future is only an illusion, no matter how persistent." So he suspected that there was an illusion going on. And if you think about it, it's always the present. You only have ever seen the present, yet we kind of think that the past and the future exist. And I'm going to break down for you and show exactly why this is true. However, Einstein also said that space and time are one thing, warpable space-time. This is, of course, the theory of relativity, which is basically 99.9% proven. Its essence has been proven. And he said that motion and gravity slow time down. These are equations for relativity. So I wondered, does time exist, or is it a misunderstanding? Is the whole time thing a misunderstanding? And I looked at what we really mean by the past and the future. I've got a very pedantic, analytical mind, and I broke this thing down to the tiniest, tiniest detail. And I asked myself, what if things didn't exist, move and change over time, but instead, they just exist, move and change? Now that seems a bit odd. You kind of say to yourself, yeah, but things need to move and change over time. But I'm saying, what if they don't? What if they just exist, and they just move, and they just change, and that's it? As things move, they don't leave a trail behind them in the past. As they move, they don't come out of the future for new things to happen. It seems very simplistic, but I can show you why it makes a lot of sense. So I began reading and thinking about time. These are some of the books I've written. Every one of these books is explicitly about time, and every one of them, in my opinion, has got a slight flaw in it, which we will break down. That's the same books again. While reading these books, I noticed specifically that they either assumed that time just existed, or they started by asking, does time exist, or what is time? Or they had a very basic proof that could be broken down very simply and shown to be incorrect if we ask one key question. And in this talk, I'm going to tell you what that question is. And if you keep applying that question, you might see for yourself that you can break time down.
There's good news and bad news. The good news is time doesn't exist. The bad news is it's kind of as if it does. You know, as humans, we're like cars that have got an engine that's always running. We are constantly wearing out, but we're just wearing out. We're not wearing out over time. So I'm going to show you that question. I'm going to show you how the universe is literally timeless. The problem with talking about time, if you've ever had a conversation with anyone in a pub about it, is that many, many, many other topics come up in the conversation. We start thinking, we think, does God exist? Does Buddha exist? Do aliens exist? How did the universe start? How will the universe end? If a tree falls in a forest and there's no one there to see it, will it make a sound? Who shot Kennedy? Who shot JR? Did we go to the moon? What happens when we die? What if we could go back in time and kill Hitler? What if we go into the future and find the lottery numbers? But my job on this little journey of timelessness is to keep it focused on the one subject, time. Now, of course, we can't just do that. We have to answer some questions, otherwise people's minds will be wandering. So we should clear up that it was actually Sue Ellen's sister, Kristen, who shot JR. So what is time, and why do we even think it exists? If you're like me, you probably didn't come up with the idea of time yourself, and that's not a very scientific thing. If you've just got an idea that's been put in your head, and you've just taken it as correct without checking for yourself, it could be a little bit dodgy. Your first idea probably came from your parents yelling bedtime and pointing to a clock. But a clock is really just a bunch of springs and cogs. And this is a kit clock that I've got at home. You buy it for kids, called Schling, whatever it's called. And it looks very complicated. When you look at it here, it just looks like a whole mess. You can't really work out what happens. But with this clock, you can break it down and you can see how it works. This is the spring. You wind that up with the key at the back. This spring drives these teeth wheels here, which drive these, which drive these, which drive these, which drive this white one. And this pendulum at the back swings. And obviously you've seen on any other clock, as the pendulum makes one complete swing, it allows this tooth wheel here to move on one click. That in turn sends a message, if you will, back here that allows this to move slightly, and so on and so on. So this entire system here is purely to make this spring unwind slowly. The other cogs simply take the drive from that spring and make these hands turn at certain rates. That's all there are. When you put it back together, you've got one of those. It looks more complicated than it is, but it's still just a motorized bunch of cogs. So really, what is time? In simple terms, we say that time consists of the past, the present, and the future. Time is also said to have a flow and a one-way direction. It flows from the future through the infinitely thin present, as you can see there, into the past. We say the past exists because things clearly happen and have clearly happened that are not happening now. And if you recognise this as England winning the World Cup, which has clearly happened but is not happening now, hardly ever at all. And we can remember these things. This is one of the definitions of the past. This is two people remembering that event. We say the present exists because we can constantly see it. And this is some people constantly seeing the present. We say the future exists because we know things will happen that aren't happening now. We don't know what the weather's going to be like. We don't know if we're going to win the lottery. We do know we're going to die, but we don't know when. Some of these things we can predict and some of them can't. So we could, in a sense, predict the sunset, but that's because the Earth is very heavy and it's spinning at a very steady rate. We can't predict the weather because it's very chaotic. As Stephen Hawking says, the future is distinct from the past because we remember the past and not the future. So this, again, is this distinction between the past and the future, and that's what I'm going to break down for you, and I'm going to show at the end why we think we can see the past and we can't see the future, and why that's not actually the case. We say time has a flow and a direction because we're born, we live, we die. It's a very rare picture of Einstein as a baby over there. Very lucky to find that. Night follows day, spring, summer, autumn, winter happen in that order. So we think that time has a flow and a direction. So we say time exists and has distinct features because there is a constantly receding past that we can see but not change, a clearly visible present in which things happen, a future which seems to constantly arrive but is also somewhat unpredictable, and it has a flow and a direction. But what do the experts think? Because I'm just a layperson. I'll explain what that means later. They say they're sure that time really exists as more than just a useful idea, and that time is complex and mysterious. This you might recognise is from The Simpsons, where they were speculating about the possible existence of a so-called third dimension, which of course in The Simpsons doesn't really exist. That's a corny joke. Galileo is often credited with being one of the first people to really work with time. Stephen Hawking, well, I've heard Einstein said this, I don't know where this quote is exactly from. Galileo, perhaps more than any single person, was responsible for the birth of modern science. And for me personally, he probably is the man who gave birth to the real idea of time as being a real, measurable, empirical thing. he started work with pendulums. Pendulums are excellent things to work with because you're in the middle of nowhere with no technological instrumentation. As long as you've got a fixed length of string and a heavy weight, you can create something that will have a very regular periodic swing. And you can refine that more and more and more. What he actually used a lot was water clocks, or clepsydras I think they're called, and ramps. This isn't his original equipment, this is kind of replicas or later versions of it. And by rolling a ball down a ramp, he could slow down the effect of gravity in a sense, and he could tell that things accelerate as they fall. And if you look at this ramp, you'll see there are a number of bells here. These are the bells enlarged. As the ball rolls down, you can hear a ting, 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 ting noise from those bells. These bells are actually spaced out, but when you roll a ball down there, you'll hear a constant ting noise, ting, 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 because the ball is accelerating. And Galileo was quite into music, had a musical ear, so he often listened to the clicks of balls going down ramps to judge the speed of things. As he rolled these balls down various ramps, he would allow water to pour into a vase or a mug, and at the end he would stop the water and then he would weigh the water. So in a sense he had an accurate stopwatch just by using a water clock. This is the kind of experiment he would do. Galileo created some of the first equations of time. S equals half AT squared or whatever. So here he's putting time into equation and showing it to apparently be something that is real and measurable and has a flow and a direction. This is the beginning of the origin of the idea of time. And as he's watching a pendulum swing, he'll be counting 1, 2, 3, 4, 5. And that gives us the idea that there's another dimension, that there's something that is tracking off at a steady rate forwards, constantly forwards in a direction that isn't up, down, left or right. But in reality, all he's doing is comparing the motion of different things. So I think this is one of the first points where things got abstract and the abstract was taken to be real. Isaac Newton founded classical mechanics on the view that time is something that passes uniformly. He thought time was just a thing that existed and flowed constantly. He thought space was an absolute thing and time was an absolute thing. And I'm kind of saying here, well, space is whatever it is, but I don't think time exists. I think there's just motion. Einstein says space and time are one warpable thing, space-time. Hawking says that different areas of space and time might be linked by wormholes. You get a very dense object, you might actually be able to warp space and time and travel from a different time and place to a different time and place here. So Hawking very much thinks that time travel is possible, and I'm going to try and show you that it's absolutely not possible. You might be able to warp space in unusual ways, but you won't also be warping time. One of his lectures, the conclusion of this lecture is that rapid space travel or travel back in time can't be ruled out. So I'm trying to show you here that time isn't just a rough idea. I should explain that half my friends think it's obvious time exists and the other half think it's obvious time doesn't exist, which I find really confusing. So I'm trying to point out here that your top bods think it does exist. If you look up on the internet, you'll find 53 million hits on the mysteries of time, 250,000 hits on time travel, 1/3 billion hits on does time exist. It's the #1 noun in the English language, so time is an interesting subject. And in Birmingham Science City, 1/3 of people think that time travel is real. So it must be true, and that was from the Sun. So. You're from Birmingham?
Yeah, I'm from Birmingham.
Okay. I can go slower, it's all right. Stephen Hawking's mad scientist paradox, if you look on YouTube, you'll find this. It's a guy who constructs a gun. He assembles a gun, then he walks around a time porthole, and he shoots himself before he's assembled the gun. And what Hawking is saying here is if you had a time shift of only a second, you could still create a complicated paradox. And he's saying this is the kind of mystery that gives cosmologists nightmares, and I'm saying it's not a mystery. I can explain that it's not possible. You can warp things, you might be able to stretch things, but there's never a past, there's never a future. So the experts think time is real, that there is in some sense a past and future, that time is part of space-time, that time can be slowed down, and it might even be genuinely travelled through. Now I've shown you why we think time exists, I want to show you why it doesn't exist at all. As I said, every book that I've read assumes that time exists, or it asks, does time exist, or asks, what is time? And when you ask those questions, you're kind of polluting the thing you're exploring. Perhaps instead of asking about time, we should just look at the world around us and ask, what do we basically see? A quick check reveals that we basically see things existing, moving and interacting. That's a planet existing, that's someone moving, how did that get there? And that's mousetrap. So there's a lot of interaction, if you can be bothered to play the game to the end, which I never can. And this leads to the key question, and this is the question which, if you take it seriously, will perhaps unravel time for you. Question is this: if objects in the world could just exist, move and interact, would this explain all that we attribute to time? So before we add the idea of time in, I'm saying let's just work with what we've got. It's very unhealthy. If you know anything about the ether or phlogiston or stuff like that, it's very unhealthy to stick in an idea and then act as if it's real. Even the Emperor's New Clothes, where the Emperor had no clothes on, everyone thought he was wearing an invisible suit. It's very bad to stuff in an idea that you haven't really confirmed and then act as if it's real. You can mislead yourself. So we're going to apply this question to the past, the present and the future. The past. I want you to consider this experiment. You can actually do this experiment for yourself. It's very easy. It just takes a little bit of concentration. Concentration is when you're focused on something, listening to it, and you're aware of what's going on around you in the room. That's concentration. You're back. So consider this experiment. You get a pen, you draw an X on a piece of paper on the pen, and then you put the pen down. Not a hard experiment. You might even be able to do that. Then again, it does involve 2 lines, so perhaps not. Now, if you do that experiment, you're going to end up with 2 things. You're going to end up with an X on the piece of paper, and you're going to end up with a memory of making that X in your mind. Together or alone, these 2 things seem to be evidence indicating the existence of the temporal past, the time-based past. We would say this happened in the past. I would look at my mind and go, yeah, I remember doing that in the past. In reality, though, I will really be looking at the contents of my head. So these things seem to prove the existence of the past, but each of them only actually require matter to exist, move, and interact now. So we put this external and internal evidence together, and we think we've concluded successfully and logically that there's a third thing, the past. Now I can say that my keys are in the pocket, but I can't really say the World Cup is in the past, unless the past really exists. And what I'm saying is here, you have to ruthlessly ask yourself, does the past really exist? If things could just move and change, would it give us the impression that the past exists? We can point to and talk about a map, for example, as if it really was the territory it represents. So we can say we're here and we're trying to get there and this is 200 miles. But of course in reality we're not there and that isn't 200 miles, that's a piece of paper. Using a map only makes sense if the territory that it represents also actually exists. So you've got to be careful. With time, we point to and we talk about memories, notebooks, notes, books, paintings, photos, videos, fossils, and so on, ad infinitum, as if they are maps pointing to and proving the existence of the past. It seems obvious. Of course this trilobite was formed in the past. Of course that's the Berlin Wall going down. Of course that's Brunel, whatever. Of course that's the whatever battle it is. But if you think about it carefully, you realise that all these things prove is that matter can exist and move and change. You can write something on a piece of paper or stamp it on a book or put some paint on a piece of canvas and it'll dry and it'll solidify. That doesn't prove that there's also another record of the event created somewhere. Without exception, all this stuff is literally just here now. You know, I could challenge any one of you to find me evidence that World War II happened and you would go out, but what you'd find is stuff that's lying around here now. Everything seems to be here now. And all of that stuff proves that matter can exist, move and interact, and we have no other proof that the actual past exists. We have an unlimited amount of this kind of proof, this circumstantial evidence, but we have no actual proof that there's really a past. It's a big assumption to make. So the question is, does the past exist? Is there a third temporal record, a time-based record of events, or is there not a temporal record? And if you think about that story with Stephen Hawking, he's considering firing a bullet back into the past. And I'm saying, does that past exist? Why is it created? What would create it? What would its purpose be? What's the mechanism that would make it? Where would it be stored? And if anyone who thinks time exists assumes it exists simply because they have memories of going to school as a kid in their head, then they may have made a very bad false assumption. And this question is the key. If you really ask about the past, it's the key, because the past existing is our main foundation for assuming time exists. We think it's so obvious the past exists, we then start wondering whether the future exists. We look at the world around us and see if we can word it as if the future exists. Because we're here at the observatory, I wanted to talk a little bit about stars. Ironically, I don't know how much time I've got here, about 10 minutes. I want to talk a little bit about stars. You know when people look up at stars and they say that we're looking back into the past? Now, I understand, of course, what they mean by that, and it makes a great deal of sense. In a sense, you can see how things are. But if we analyse this very carefully, asking ourselves the question, what if things just exist and move and change, we get an interesting result. This guy's here, he's going, wow, I'm looking back into the past. The star that made this light may no longer exist. Very bad English. A lot of stick men have problems with their English. When we look at the stars, we say that we're seeing them as they were in the temporal past, and that we are, in a sense, looking back in time. And I think you have to be very careful using these words like past and time, because they can start to gain some kind of a reality through familiarity. But imagine this, if you're on a tennis court and someone whacks the ball across the court and they hit you in the head, you never go, wow, I'm actually feeling the temporal past. I'm being influenced by something that happened 2 seconds ago. How extraordinary. And there's no real difference between a photon travelling through space and hitting you in the eye and a tennis ball travelling across a bit of grass and hitting the head. They're just things that exist now, and they move and they change and they interact. We break down what a star is. I'm sure everyone here knows what that is, but starlight is actually what a star is doing. But we can misinterpret what we see. Out in space, somewhere, a load of hydrogen and interstellar dust, lithium, whatever else, fall together to make an object. Under gravity, matter fuses and light is released in a rapidly expanding sphere. The light will expand at the speed of light, of course. When some of that light hits our eye's lens here, it's regrouped to form an image in the back of your eye. It's a very odd thing, but when you look up at the stars tonight, you'll see that the starlight covers your entire body. It covers your entire lens. It's not a point of light that goes through your lens. It covers your entire lens, and then your lens regroups it into an image of the star. So we actually see this, not this. We don't see the star, we see the image in the back of our eye. It's a very uncomfortable thing when you fully realise it, that everyone in this room is only seeing the back of their eyes. You think you're seeing something over there, you're not. You're seeing something here, but we'll get distracted on that. As the sphere of light expands, we'll still see this image. We're inside the sphere of light. The star has been burning for millions of years, whatever. As the middle of the star dies, even if it burns up all its fuel, but there's still light heading towards us, we'll still see a star. And we will say that we're looking at a star that no longer exists, but really all that's happened is that star is now this big shell of light. So all of this can be explained if things just exist and move. If that shell of light goes past us, we won't even know the star's there. But people behind us will still be able to see it. So starlight is what a star is doing, but we can misinterpret what we see. Being in this situation, saying we're looking at a star that is dead, is really over-interpreting what we're really seeing. We're just seeing what we're seeing, an expanding shell of light. It's a bit like looking at a ripple of water and saying, wow, we're looking at a raindrop that's dead and no longer there. Well, you kind of are, but really you're just seeing what you're seeing. The Hubble Deep Field image took an exposure of about 500,000 seconds of light, and it's said to show us galaxies as they were billions of years ago, and of course it does in a sense. 500,000 seconds of exposure equates to about 150 billion kilometers of light. That seems like a hell of a lot of light. That's what happened. They didn't do it all in one go because they had to damage the sensors and the telescope. They took a few different exposures at different wavelengths, whatever. The nearest star to us is Proxima Centauri, which is 250 times further. It's 37,500 billion kilometers away. So we got the Hubble here taking 150 billion kilometers of light. This star is 250 times further, 37,500 billion kilometers away. We're not seeing the past here, but we're marveling at the actual contents of this little cylinder of space. That's what we're really actually doing. Of course, we can deduce a great deal of useful information from it, but I think we shouldn't get lost in realizing that. I put this little butterfly net here to show you it's very similar to standing in a field with a butterfly net and just waiting and seeing how many things come into it. So that's what we're marveling at. So if things can just exist, move and interact, that explains this and explains we're not really seeing the past, we're just seeing something that's very fascinating. The present. If there's no past, we still say things take time to move in the present. This seems obvious. Okay, maybe the past doesn't exist, but there must be time. How else can we move? We could say a car does 100 miles an hour, and that's obvious. Cars exist, and miles exist, and therefore, of course, hours must exist. You've got to have the three sides of the triangle. That seems to be obvious. Let me see if I can break it down. Essentially, all we ever actually observe is that cars move and the Earth spins, and we can compare their motion. It turns out that if you look at a palm tree on the equator, that palm tree will be doing a certain speed, and you can express that speed as around about 1,000 miles an hour. It's actually 25,000 miles around the world, and spins once every 24 hours, so it's doing about 1,100 miles an hour here. And if it happens that the car's doing about 100 miles, we could express that speed as being 1/10 the speed of a point on the equator. You could phone up a mate and say, oh mate, I got pissed last night, I got done for speeding. How fast are you going? I was doing 1/10 the speed of a point at the equator. He goes, you idiot, you know that the speed limit is 1/20 of the speed of a point at the equator. You can express that speed completely legitimately without using any mention of hours or time. It seems to be the same thing expressed a different way, but there is a difference. What's the difference between miles per hour or 1/10 the speed of a point at the equator, or expressing your speed in terms of something else? It's not a semantic difference. Miles per hour suggests that miles exist, and in the same breath that hours and thus time exists, and that time passes or is needed for motion to be possible. Time suggests that the past and the future exist. So when we say miles per hour, we're actually suggesting, oh yeah, we need this extra thing called time, or even if we don't need it, it always passes. If you just say you're doing 1/10 the speed of a point in the equator, all this suggests is that things can exist, the car and the earth, things can move, and we can compare the speeds of different things. And that's all it suggests, and that's all we observe. So I say it's wrong to make another assumption unless you really need to. So we wrongly assume that miles per hour is a proof that time exists and it's needed or passes as things move. Brings us to John Harrison. As mentioned, King Charles II founded the Royal Observatory in 1675 to solve the problem of finding longitude at sea. So this guy created a lot of very accurate clocks and brought them to these guys, and they said they were rubbish and sent them away a few times. Cut a long story short. The problem of finding longitude being this. This is the Greenwich meridian, of course, going right through Greenwich there. Latitude, your position around the Earth up and down, can be calculated by looking at the stars and working out the angle to those stars. The pole star, for example, is a very good star to look at because it's always directly above the North Pole. The problem with longitude is that the Earth is constantly spinning, so you can't use the stars around you. Hence it was said that one needed to know the right time at sea, and they put out a prize which was something like £2 million at the time. So to this end, Harrison created a large number of clocks, and you can see them in the museum around here, these very famous and classic clocks. Excellent, excellent pieces of machinery, I wouldn't deny them. His own clock at home was accurate to 1 second a month, and this was a few hundred years ago, whatever. So John Harrison presented the Board of Longitude with numerous accurate clocks with hands and numbered dials, such as this. And these are, of course, to apparently track and display the right time. But consider this. No matter what mechanism used to drive it, whatever the device was called, the Board of Longitude would have been satisfied with a mapped globe rotating at a rate matching the Earth with a marker indicating where the sun is. This seems oversimplified, but if you think about it, if you had something like this on a ship, you could always work out where you were. You could look at where the angle of the real sun in the sky was, you could look at your model of the Earth as if you were out in space, you could work out where you were. And with this device, a sailor, knowing their latitude, could constantly work out what their longitude must be by applying the angle of the sun to a machine with no mention of time. Because we say we want an accurate clock that tracks time, but we don't. We really want to know exactly where the Earth is, because all we ever observe is that the Earth exists and it spins, and it's always now. Which is what I've just said. This is actually a watch that I own here. It's a 24-hour watch. I photoshopped the other hands out, and that's really nice. You can point that hand at the sun and it'll just track the sun all day, because that hand rotates at the same speed that the Earth rotates, which is all we want to know, because we can't walk around on the other side because it's dark. The future, we've got time? Yeah, about just enough time to nail the future. Even if the past and the present don't require time, surely the idea that the future constantly arrives is proof that time exists. There are people talking loudly at the back. We didn't know that was going to happen in this side. We thought they'd be much more polite. But do you really see the future constantly arriving? Consider your local park and literally go down and do this. Sit on a bench and look in the park. You will see countless things moving. They'll be moving in orderly or chaotic ways, but you won't see the future constantly arriving. You might express what you see in terms of the future constantly arriving if you assume time exists, and if you assume the past exists, then that's how you'll frame it. But what you'll really see is that things move. And things only ever move if there's energy inside them coming out, unless they have momentum. So this burns because there's wax in there, this burns because there's fuel in there, this burns because there's fuel in there. Where anything is happening, energy is flowing or being released. And energy can be released in a smooth way, or a chaotic way, or a sudden way. And we might call these different ways predictable or unpredictable. But none of them prove the existence or arrival of the future. If we put this all together, and I'll wrap this up shortly, we can understand why we say we can see the past but not the future, and see just where Einstein was both right and wrong about his distinctions between the past, the present and the future. When we talk of the past, we're actually talking about some particular contents of our minds and referring to them as the past. We actually look at something in our heads, like if I ask you the name of your first school, you'll find an answer in your head, you'll talk about it as if it is the past. But in reality, all it really proves is that you've got a formation of atoms and ions in your head. When we talk about the future, we're creating images in our minds and calling them thoughts about the future. So I can ask you to imagine what this place will be like in 1,000 years. You can imagine, but all you're doing is imagining something now. In fact, things are constantly happening and changing in orderly or chaotic ways everywhere. But we can't see what is far away or physically round the corner. So the question is not, why can we see the temporal past but not the temporal future? Because neither the temporal past or the temporal future actually exist. You can never see proof of them. You only ever see things here and now. All we have to really ask is, in an ever-changing world, why can we see the contents of our minds but not around corners? And the answer to that is much more obvious. So that basically, ladies and gentlemen, is, I've got someone hovering here waiting for me to get off because I've run out of time. The deal was I could only talk while the Earth rotated through 7.5 degrees. We'll jump through Einstein, relativity, genuine time travel. Shame you're going to have to come to one of the other talks. I just want to leave you on this slide, which is an appeal. I've read this book. I put my heart and soul into it. It might be right, it might be wrong. I'm scientific. If it's wrong, it's wrong. I put my hands up. But I would like to make some contacts here. So if anyone's interested in talking to me, I'll be hanging around here. Please talk to me. Please give me your email. Anyone wants to buy a version of the book, let me know. I'll try and arrange that. Anyone wants to book me for a speaking engagement at college or anything else like that, or just in personal, I'll do that. If there's any editors or somebody who'd like to read and review this because they think it's probably wrong, or an agent, or any psychiatric help, please speak to me. Ladies and gentlemen, that is why the universe is timeless. Thank you. Woo!